Good afternoon, everyone. So I welcome all of you to the uh, afternoon session of day one of this international conference on computing, communication, and learning. So in this session, we have keynote talk by Professor Prasanta Jana. So before start, we'll talk about federated learning, today's machine learning paradigm. So let me introduce her. Professor P.K. Jana received MTech degree in computer science from University of Calcutta in 1988. PhD from Jadavpur University in 2000. Currently, he is one of the senior most professor in the Department of Computer Science Engineering, IIT ISM Dhanbad. He has contributed more than 250 publications in his credit, co-authored 5 books and 3 book chapters. He also produced more than 16 or 17 PhDs. As a recognition of his outstanding research contribution, he has been awarded as senior member of IEEE in the year of 2009. He is also a recipient of Canara Bank Research Publication Award in the year of 2015 and 2017. He is also among the world ranking of top 2%, including all the fields, Indian scientists in artificial intelligence, which is the survey conducted by Stanford University, USA, which is published in the year of November 2020. His research interests include cloud computing, machine learning, wireless sensor network, fog computing. So with this brief bio, I request Professor Jana sir to start the keynote.
I believe that the voice should be audible to the last one. This one is okay. Make it. Good afternoon to all of you. My voice is audible to all of you. Okay. You see, I can see Professor Roth. I'm very much fortunate that I could meet in this particular international conference. I pay my sincere thanks to the conference organization for inviting me to deliver the keynote speech in this conference. Special thanks to Professor Sanjay Panda. Again, good afternoon to all of you. Like just machine learning these days, all you are aware that is the buzzword, and someone's code, let it be Bill Gates or I could not, or Mark Zuckerberg. Like if you do not learn the machine learning, then we will become the dinosaur. I want to be will be extinct, right? But machine learning has a lot of areas. It's not the traditional classifiers like the decision tree, support vector machine, or it will be your neural net, maybe the ensemble technique, you learning, right? But there are a lot of development on this particular subject area. And the people have started claiming this machine learning. Now this is a part of the big umbrella, the artificial intelligence. Although artificial intelligence mainly in the old days that was on basically the search algorithm and basically use of lot of heuristic. But you know that whatever we develop any kind of metaphysical approaches, right? They are also now the part of the machine learning to start claiming it. Reason is very simple. Reason is very simple that most of the real-time or real-world problems which we actually solve, they are NP-hard or NP-complete problem. And being an NP-hard or NP-complete problem, Either you can develop the approximation algorithm because optimum result you may not get it always, right? Or so you can take the help of the heuristic or data to provide the approximate solution. Now, federated learning in the recent years has gained enormous attention in the research community. So that's why I have selected these particular topics. So this is my institute where I work. It was established in the year 1926, a very premier institute. Basically, it was very famous for mining, petroleum engineering, and there is also special branch like fuel and mineral engineering department. And they have the geology and then geophysics department as well. Right, and the people graduated from this institute are serving worldwide in various reputed organizations, right? But the diversification it was started from the year 1998. Then, because of the pressure of the existing engineering branches, it has been converted to the IIT in the year 2016 October. And this is the department where I work, Department of Computer Science. The organization of my talk, I go to the background, federated learning, ongoing research, scope and future direction of the research. As you all have, the world has witnessed tremendous growth of the IoT devices. Right? Billions of IoT devices are now connected. They produce huge amount of data. Right? And this data can be analyzed to provide some kind of services in various IoT applications. Right? What are the application size? The growth of the IoT devices, and you can notice it is predicted at the end of the year 2030, it will reach to 29.4 millions. You consider yourself that how many actually electronic gadgets or the devices you are actually using. You have your laptop, you have your mobile, you have your smart watch, and it is predicted that after the end of the 26 or 27, every people will have this kind of the electronic devices which can generate huge data. And this is the picture of the generation of the global data sphere. And you can see that the end of the year 2025, it will reach to 175 gigabytes. Right? This is predicted. So we require a huge processing power and the storage. And cloud is the only technology till date which can be used efficiently to store the data for analysis and for the processing of it. But what is the sources of all this data? Primary sources to be the industry, right? Banking sector. Then you have the smart applications related to the smart city, with smart transportation, smart healthcare, smart agriculture, and so on. Right? And we need such data analytics to impart some useful information. And the information gained from the data analysis can be useful on the market analysis till the fraud prediction, fraud detection, and then science exploration, right? Take a look that where is the requirement of the ML or the machine learning. Say this is a agricultural field. We have deployed number of IoT devices just to predict what is the soil fertility. right? Or we may predict the moisture level, which can help for the irrigation, right? For the irrigation. Or we can use the drone driven solution, which can take with the smart camera, take the images from the plant leaves and can send to the cloud just to predict whether the plants are suffering from some kind of the diseases or not. And again, it will provide the services whether there is a requirement of the pesticides or herbicides or not. Today, if you go for the smart transportation system, there is a Google map. We are able to predict that what is the traffic situation in a specific road. Then it can suggest some kind of the alternative route, right? So prediction of the traffic, let's say that it all depends on the machine learning technique. Not only that, in a particular intersection, till today, just we are using the old system, which is basically the timer based. Say let it be there are 4 pathways and there is an intersection. The signals are there. Whenever the signal will become green, then the car passes away through that. But this timer-based system has a lot of degrees. Say it may fail. In that case, there may be a chance of accident, especially car to car and pedestrian to car as well. Why should we not take the control that all the devices should be equipped with the IoT devices, and then the signal system also to be equipped with the IoT devices, and there will be collaboration, like sending the information from one vehicle to another vehicle to control that particular system. So this will be automatic, right? If you find that in this particular pathway there will be any kind of the jam, then all the cars it will be down. So this is very much automatic, and this is really taken care of it. But whatever be the case, we require the ML for the prediction, for the classification, for the analysis to provide the services for all the IoT applications. Now, the traditional approach for the data analysis using the machine learning, the data is collected from the IoT devices, and this collected data, say let it be images, video, etc., are actually sent to the central cloud server. Now, based on the particular data, the cloud prepares a machine learning model, right? So whenever any data, any task, it will be provided by any IoT device to the cloud, then the cloud applies that particular model and then sends back the result to the IoT. So here's an interaction that IoT, they are all supposed to send the data to the cloud server. Based on that particular data, cloud server prepares a machine learning model, right? And model is kept with it. Then any query, any task, it will be given by the IoT devices. Then the cloud utilizes that particular machine learning model and sends the result to the IoT devices. Right? Say for example, I am taking an example, monitoring the old person. Okay, with the stick, he is actually moving around, like inside the residential campus. Right? You maybe put some lot of body sensors, which can actually generate the data related to the blood pressure and then heartbeat, all sugar level, etc., continuously to the cloud, right? And like cloud has the analytic model, like healthcare analytic model, and the data is applied to that particular cloud model, and the cloud can send the result which can be in the form of a warning in his smartwatch that okay, you should not now move around, you should take a rest because your pressure level has become high. So this is one of the examples. Now, this is the traditional approach, what I told, that there are all the IoT devices, say smart robot, you have the UAV, that is the drone, and then smart car. They send the data to the cloud server. The cloud server prepares the model, which is indicated by means of the neural network. And whenever any task which is given by any IoT devices, it is applied on that particular model, and then it sends back the result, right? But this particular method has a lot of demerits. The first demerit is that all the IoT devices data that will be sent to the cloud, which is very privacy sensitive matter. So, for example, enterprises, they may not like to send any kind of the data from their desktop or laptop, etc., to the cloud. Right? Say, for example, Amazon, daily transaction sales, or related to banking, credit and then debit information should not be sent to the cloud. Right? So they are all the private data. So whenever the IoT device will send the cloud data, it actually compromises the privacy. This is the first thing. Second, since enormous amount of data is actually flowing to the cloud, it consumes huge network bandwidth. This is the second thing, right? And third, that the distance between the IoT device and the cloud, all you have know, it is known to you that the cloud servers may not be kept in India, like Microsoft has the cloud center in US, right? And if I try to, like send from India, right, to the cloud server due to this physical distance, it actually offers some kind of the distance, right? So latency, that is a big problem, which may not be applicable for the sensitive applications. So, for example, register management or the smart healthcare, etc. So, they are basically the three demerits of this particular technology that we are able to overcome by means of the federated learning approach. Here, we do not require to send the data from the databases. Okay? Rather, the models, it will be made locally inside the IoT devices, in the IoT devices only. Models will not be prepared at the cloud, right? So models, we are not sending the data from the IoT devices to the cloud, but models, it will be prepared at the IoT level. And all the model parameters, what kind of parameter this is? Say, for example, that our model is neural network, right? And the neural networks has number of weights and then biases as well. So only the if weights and biases are given, along with how many hidden layers will be there, what will be the total number of input layers. I want to make in the input layer how many neural cells will be there, in the output layer how many cells will be there. If we send all this kind of the information, the model, it will be available. So rather than sending the data, models, it will be prepared at the IoT level based on their local data, and then model parameters are sent to the cloud. Then the cloud aggregates all the model parameters collected from all these IoT devices. And then that aggregated parameters that will be useful to prepare a global model, and then it sends back the global model parameters to all other IoT devices. Then again, IoT device will refine that local parameter based on their particular data sets, and again send the updated parameters to the cloud. So this method is to be continued unless or until some accuracy is achieved or the loss function is minimized. So this is the thought behind the FL architecture. I'll give you the clear picture here. You know, they are all the IoT devices. Smartwatch is there, smart car is there, smart home is there, then smart transportation, etc., etc. Right? Now, one, it says the IoT devices is actually sending a request for the model preparation to the cloud. Right? And then cloud, they are actually sending an initial model to all the IoT devices. That is the level S2. Then these models, it is trained locally, right? And so by means of the 3 and by means of the level 4, it is they are sending the local parameters to the cloud. And in the 5, the cloud model, the cloud actually aggregates it, which has been indicated by means of the summation. And then aggregated model or the model parameter is sent again to the all IoT devices, which is indicated by means of 6. I believe this is clear. In the one,
the global one, in the IoT level, it loses its local security.
no, the global parameter, whenever it will be sent by means of the cloud forward to the IoT devices, that global parameters again it will be defined by training the model over the data at the IoT level only.
So, is there any model or is there any protocol which says that you can preserve the local characteristics while downloading the global characteristics?
But you know that we do not require any kind of the local model because local model may not be that much efficient. The reason is that it has a limited set of data, right? Other IoT devices has another data. So I want to prepare a model in which enormous amount of data to be utilized, where a single IoT device may not have. It is a collected data. Say, for example, SBI IoT ISM branch has a set of data, but SBI have lot of other branches too. So if you collect the data from all other branches and prepare the model, that model it will be optimum model, rather than the model which is applied only for the IoT ISM. So that is that.
But I still think that there can be a protocol where the local characteristics can be retained. For example, some local one, L1, L2, L3. There may be some characteristics which is different from L1 to L2.
But why do we require that? To maintain that particular significance. Whenever one global model, it will be efficient model, it will be provided to the IoT devices after certain iteration, after certain communication round. Then the global model, it will produce the better result than the local
For
model.
example, the precision agriculture, what you said, right? The precision agriculture per type of one agriculture, for one crop, may be slightly different for another crop.
That comes under another kind of the research, which is basically dealing with the data, which is basically known as non-IIT. Non-IIT, that I'll discuss it. No, that you are absolutely correct. The model which has been applied for the case of the wheat Prof, the same model not necessarily applied for the paddy plant. Right? Rice crop. So there are the two different models. I need to, because the requirement for the soil fertility, that will be really different from the wheat and then rice as well. Even the irrigation system is also very. For the paddy plant, they require huge amount of irrigation. Right? For the wheat, we do not require that much irrigation. So models it will be different. So whenever we will be trying to produce a single model by taking care all these aspects that they have the different characteristics, right? That will be dealt with the help of the clustering. What we'll do only with the rice model, it's not from the single place, we'll take care of the other places as well. Right? So this is basically dealing with the non-IoT data. The local model for any application, it will be the same. Yeah, for the different application, the different models will be it will be a problem. So that's why there is a dealing of the non-IoT data. You see, I have taken care for the smartwatch, the data which is dealt here. that not necessarily with the help of the smart car. Smart car has the different kind of information. Okay,
That's what actually lets me to think that the smart car
and this I have in the scenery is the known identity. It's not the uniform data or identical data. They have the different identities. Identity basis. Yes, absolutely. IIT devices must have the computational power so that it can train that model using its own local data. But all the IIT devices may not have that much processing power. Say so my smartphone may not do that. So this is also a valid question that actually comes under the selection of which is basically known as the clients. All IoT devices should not be involved in the FL process, in the federated learning process. This is basically research which is basically known as the client. I will come to the particular ongoing research that how to select the clients. Means clients I want to mean all the IoT devices will be able to participate in the model preparation. Other IoT devices may not. All IoT devices are not that much powerful. They have a lot of other limitation as well. So memory may not be there. You know, that much memory may not be there. Yes, it's because most of the IT devices, some IT devices will be battery powered. They have the limited span. Okay, they need to recharge this also. There are a lot of limitations. That is basically known as the client selection problem. I'll come to that particular. Do you have any questions? Then should I proceed?
No, please proceed. I just
Okay, no issues. This is the process I needed to saying. There are actually two approaches. One is the top-down approach, another is bottom-up approach. I want to make a top-down approach. Say, for example, the cloud will send the initial model to all the initial model. That model may not be optimum model. Initial model to all the IoT devices. Then that initial model it will be trained with the local data of the IoT devices, and then they will send the like parameters, local parameters to the cloud. They will aggregate and again send that. This is one. Another one it may be the IoT device will initiate the local model preparation without any interference of the cloud. But the local parameters they send to the cloud, and then cloud aggregate itself. So this is the top-down approach and bottom-up approach. So this exactly this top-down approach, I try to explore by means of this the three steps process. Look here, W0G, that is the initial blueprint. 0 means at the beginning, okay, and at the GTC, every client at the time period T will prepare that particular model. Now at they send to the global, and they will try to minimize the loss function, which is basically indicated by means of the FPWTK. And again at the T+1 time they'll send the global model, etc. for the aggregation, etc. Okay, so this is basically the three-step process, and the step 2 and 3 it will be repeatedly. It will be repeatedly like executed, and unless and until the loss function is minimized or achieve some kind of dimension, right? And you know that number of FL algorithms have been actually developed, but the most popular still the people are working or refining it. That is basically known as the FAIR approach. And here you can notice is that. This is the aggregation. This is the cloud server side, the step 5 to 7, right? And the local model, local parameter updation, that is from step 5 to 12. And here you can see eta is the learning rate. And this is the, I want to mean, we are using the gradient. And that way just we are able to calculate what is the loss function. If we find that loss function is going to be minimized, then we are happy because we have been able to achieve certain kind of the application. Now, compared to the conventional cloud-centric approach, this FL has advantages. The first advantage is that we do not require to send the data, so there is no compromisation of the privacy. Second, it does not really consume that much network bandwidth, because rather than sending the data, we are already sending the parameters. And third is that since the models will be provided at the IoT level, so we can take immediate decision, say detection of any kind of event, etc. locally. So latency will be solved, right? So these are the three goals of the federated learning. Okay. Now come to your point that all the IoT devices may not be, they may be reluctant. There are some reasons, because they have the limited memory power, right? Memory size and then processing power. But you know, some IoT devices, they may not be interested to take part in the FL, although they have sufficient processing and as well as the memory, right? The reason is that, you know, this is a kind of the social welfare, because the cloud will be preparing the model, right? And they will send to it to a particular model that may not be useful for certain kind of IoT devices. So they may not be interested to take part into the FL process, right? And some IoT devices, they will become the client, but you know that they are very lazy to send the updated parameter to the cloud. They are basically, this is basically known as the standard problem, right? They are very much lazy. So that's why the client selection is a very important topic, and there is a lot of challenges here. A lot of research has been taken care, right? Incentive based is there, reputation based, etc. I'll go through only these two solutions. I'll give you the overview, not the details, because if I try to explain the IEEE paper, and say it will take 2 hours, I believe. So I'm giving you the just idea. See, this is the reputation based. Reputation basically an integer value, right? At the beginning of each round, every clients or the every IoT devices who will take part in the FL process will be given the equal reputation value. Equal reputation value. Now, depending on sending the how much useful parameters they are sending to the cloud, depending on it, the reputation delay, it will be incremental or it will be decremental. Now, if the cloud has checked that some IoT devices has actually sent the malicious parameter, it may happen malicious parameter. Why it is, I'll let you know. Malicious parameter, in that case, its reputation, it will be detailed, it will be decreasing. Otherwise, if the cloud will see that it has sent the useful parameters, then its reputation, it will be increased. And then if 100 clients are involved for the model preparation, then we can select, let it be top 55 clients who have actually scored the reputation value up to some standard level. Then we can select 55 clients and rest 45 we just discard. So this is one of the client selection problem. But you know that, you know, who doesn't want that my reputation always it will be very high. So there is a competition among it. So in that case, most of the researchers actually follow the game theoretical approach. In a game theory, it's a very classical topics. This is a part of the advanced research. All you are aware that you know there is a game between the clients just to score the high, high reputation, right? So that's why most of the research are actually based on the game theoretical approach. And again, this is the competitive game I got. So this is one. Another, you know, the clients, they may think that why should I prepare the model? What will be my benefit? I'm preparing the model to give the services to the other clients. What will be the benefit of mine? So that's why the researchers has also developed the concept of, which is basically known as reward method, or the giving the incentives. The incentives will basically in the form of the rewards, or it may be the monetary, right? Or it may be that getting the best model from the cloud, right? Or other kind of the facilities from the client. Say for example, a health organization, right? A health organization has pathological data, has cancer diagnosis data, right? And one client related to the health organization is actually dealing with the pathological data and it is producing the model, right? But it does not have any cancer detection model, whether the cancer cell it is the malignant or it will be the non-malignant, right? So the client which has actually prepared only for the pathological data can take the health, can take the model from other client who has actually prepared the model for the cancer detection. So that way that benefit it will be given, right? It is only utilizing its own pathological data, but it is utilizing the model who has actually prepared for the cancer. So that kind of the benefit it will be given. So this is basically on the incentive. Therefore, incentive mechanism have to be carefully designed. This is very much important. That how to design, what kind of the incentive we take care. This is basically the optimization problem. Even the client selection is also optimization problem. The next research, most of the FL area, that is reducing the communication time, because the distance of the IoT devices and the cloud server is with physical distance is huge. So most of the research are based on the communication, because communication, that metrics, that is very much important, right? And a lot of approaches have been taken care. A reason is that in the FL process, communication time actually dominates the computation time. Now the researchers have thought of the two kinds of the solution. The first solution, why should we not reduce the number of communication buttons by increasing the local computation? This is the first approach, right? How? I'll explain it, right? And second is that, second approach, that we go for the importance-based updating, because all the parameters, they may be very close to zero. They do not have any value. So why should we set the parameters? Those parameters which will be very 10 to 0, they will not contribute in the education process. They should be dropped. So if we drop the number of parameter value, then it will take less communication time to the client. So these are the two approaches have been taken there. The next one is again this is the dealing between the IoT devices and then cloud. Communication problem is there. So just to overcome, some people have also thought of distributed learning. In the distributed learning, cloud is off. The central server, that is a single point. So if it crashes, then your global model that cannot be proposed, right? So the basic idea for the distributed learning is that all the clients, they actually send the message through peer-to-peer communication, and that way they update the local model, right? They update their local model. And although there is no global model concept, but by that way, by exchanging the local parameters, they can reach to the global solution. I'll try to illustrate it by means of this figure. This is the traditional approach, centralized system. Look here, this is our central server. All the IoT devices, they prepare the local model and sending the local parameters to the central server, right? And then central server aggregates, and again, they send back their parameters to all the IoT devices, and this way, after certain rounds, the global model is produced, Whenever the global model is produced, then it is delivered to all the IoT devices, right? If it crashes, then the global model cannot be obtained. On the other hand, this is the distributed approach. This distributed approach, what exactly we do for the case of the distributed network as well, right? Peer-to-peer communication. Look, IoT devices, they are preparing their own local model, and they are exchanging the local parameters to all of them. To all of them. Say, for example, whenever the client one will receive the local parameters from rest of the clients, it will aggregate it, right? Similarly, for client 2, whenever it will receive the local parameters from all of them, it's aggregated, right? And whenever they will aggregate it, that aggregated parameters again they will try to exchange with one another. So after certain terms, what will happen? Everybody will have the global model, right? But global model, that is without the help of the system, right? But there is a catch. The first catch is there. It really requires the communication overhead. But we are safe. The reason is that, you have the clients at the edge of the network. Cloud is far away, right? All the edge nodes, they are actually connected by means of the RAN technology, random radio access network, maybe the Bluetooth or maybe the Wi-Fi, etc. So it's not the communication latency which really happens between the IoT device and the cloud server. This is only through the RAN technology. So this is faster, right? Although there is a coverage. But this is the thought of the distributed part. Next, scheduling conversations is very much important. Okay. Here, look, exactly the same thing is also applied for the case of what should I call it? Scheduling. Here it is synchronous. I want to mean, say client 1. All the clients, they may take the protocol that unless I receive the local parameters from all of them, I will not execute. This is right. This is basically synchronous. But other form of the aggregation, whenever client 1 will receive the local parameters from any other, it start aggregation. Say it receives only from client 2 and then client 5. Then client 2 and client 5 parameters are aggregated at the client 1. So this is the asynchronous mode, right? This both it will be there for the distributed here, but both have their own merits and as well as the limits. Exactly the same thing is happening for the case of the scheduling, because the optimum scheduling can play a vital role, very vital role in minimizing the energy consumption as well as the incrementing this value, as you said. So improper scheduling can lead to the slow learning, which is not good for the delay-sensitive applications like register management or the smart healthcare. So existing scheduling, it will be of the synchronous and asynchronous, and I tried to explore by means of these 2 figures. This is the synchronous mode. Here the IoT devices is there. The first IoT device is sending the local parameter at t time, but it has not aggregated. Then at t+1 time, the second IoT device has sent it. Then at t+1 time, at the end of the t+1 time, it is aggregated. This is synchronous. So whenever cloud will receive the local parameters from all of them, then it will synchronous. It will aggregate. Whereas propagation asynchronous, as and when it will receive it, it started again. This at t time, it has received only from client 1. It's a aggregation has been taken there. At t+1, again same aggregation.
This case, all of them will send at the same time.
Is that asynchronous? Synchronous. No. Maybe
In both the cases.
In both the cases. If it is there at the same time, we are failed. There is no communication overhead. But so that's why there is a you were actually rightly pointed out, because it actually questions that how much delay it will be taken here. Because if this is basically known as the stacker effect. Say some IT devices will be very lazy to send their local parameter to the cloud. Will it be wise that cloud will wait till that time after 1 year? So that's why the researchers has been taken care. If some researchers actually simulated, if 80% of the clients send the parameter, then everything, and they get the better result. They simulated 75%, 80%, 90%, and check whether how much accuracy is there, and whether energy is minimized or not, whether communication overhead has been minimized or not. That way, okay. Same thing is for the case of the asynchronous mode. Now, security. Let me confess that I do not have any knowledge about the security, but just for the sake of the discussion, right? How the security, because without security, any communication system will be a fail. And here we need to send the data, we need to send the parameter. Anytime the data may be forced, maybe hacked by the hackers, etc. So some aspect of the security will be taken care, although I am not expert on the security aspect, but I try to point out that hackers can crack the passcode of the IT devices, and so that they will be able to leak the private information. So IT devices, say my mobile, say I have stored some of the banking password, or let it be SBI first aid. What is not there? Everything is online these days. So it's very difficult, right? OTP, hacking the OTP is very difficult. Okay. So this is one. And second is that we're actually sending the parameters. So all these parameters can be intersected to 4G. And if these forced parameters are actually sent to the cloud, think how the global model will be efficient. Cannot be efficient. Okay, so based on these two ideas, several attacks have been classified. One it could be the data poisoning attacks. Right? IT devices, they are generating the data. And some hackers, they are actually poisoning the data. There are benefits. Say there are benefits from some dishonest businessman. Say I am preparing the model for my shoe items, right? I am a seller, Makabuki, let it be Liberty, let it be Bata, etc., etc. Right? Let it be from the Pro, right? So I got my model that which particular shoe that is really preferred by a number of people, and that particular model of that particular shoe has the highest priority, so that people will be greedy to purchase that item. In the meantime, some business dishonest people, they prepared and they gave some kind of the brand name and then forced the parameters. And by that way, they can see the model which has been prepared. It is not from the Liberty, it is not from the Bata, it is not from the Pro, it is from other, and it is getting much more popularity. It's okay. So this is the forging the data. So only for the business purpose. So we have to be careful about it, right? And another is that parameters poisoning it will be there, because local parameters need to be sent from the IT devices to the cloud, right? So parameters may be forced, so we have to take care about it. You see what step we can take. The step we can take like this: whenever we try to communicate between the IT devices and cloud, the security, the technique, especially the blockchain, can be applied. every round. And now we have to check whether the parameters have become the malicious or not. It's okay. So we have to check it, applying the blockchain for every round of the communication. Parameters sending between the IT devices and actually blockchain has been applied.
Communication cost will be very high.
Huh?
Communication cost will be very high.
No. Communication means we need to check.
Every level you have to check in.
Not every level. Whenever the IoT device will send the local parameters to the cloud, right? There we'll check through the blockchain whether the parameters have become the malicious or not. If it is malicious, we'll stop it. If it is not malicious, we'll try to see. So only time it will take to check whether this is the malicious parameter through the blockchain. So we are supposed to run that. Some processing time it will do more. But we are safe. Okay, because we are able to produce this. And then again, there is a free riding attacks. Some clients may be clever. They will not contribute anything. Or they may contribute, there may be use of a very small set of data. They are not utilizing their full data for the model preparation. But they are taking the advantage of the bullseye model. That is basically known as a free riding attacks. I am not contributing, but I am enjoying the whole model. Okay, we have to take care about it. Most of the IoT applications, they deal with it's not the support information decision tree or the old classifiers, right? These days, the bulk amount of the data, we use the deep neural networks, CNN, nesting, etc. And there is a huge number of layers, huge input cells, huge number of output cells, etc. And the number of parameters, it will be huge. Say there is a huge of the huge. For analyzing radical images might include tens of millions of parameters. Can you imagine what will happen if all these parametric values are sent to the cloud? And there is always chance to hack it. You see, if we send only the 2 parameters, right, and if we send the millions of parameters, hacking of the millions of parameters, the probability will be very high. Okay. So thus it is drastically increased the communication cost between the clients and the global entity. So we need to split the model, right? The neural network model to be split. This is one approach, for example. Here it is the original neural net has been split into 3 levels, just to reduce the number of parameters. And they are communicating before going to the cloud server, right? And here, and then synchronous the models, they go for the local parameters. So this is what model splitting. This is the current research. Now the communication, we are still with the communication. Say for example, whatever be the case, except the distributed learning, there is an interaction between the IoT devices and the cloud, right? Why should we not take the advantage of computing? In the fog computing, what has happened? We actually put extra layer in between the IoT devices and the cloud server. And some fog devices we are able to deploy, which will be at the edge of the network. And they can create the all the facilities like the cloud. That's why they are basically known as the mini clouds. Okay. And that way, so aggregation, which is being done by means of the cloud, that can be taken care by means of the fog layer as well. So this is one of the architecture. So for example, they are all the IT devices, right? Initially, these fog devices were not there. So there is an interaction between IT devices to the cloud, right? Now, near to the IT devices, we have actually deployed some kind of the fog nodes, which are basically the Federated server or the mini server or the gateways, access points, etc. So they have processing power, not like the cloud server, but they have enough processing power for the model preparation. So IoT devices, rather than sending the local parameter to the cloud, they are sending to the fog servers. And it is very close, because this is physically connected, and this is through the RAN technology they are connected, right? So what we can do, many times we can have the local communication between the IoT devices and then fog server, and the real communication with the cloud. That is we are able to prepare, right? The communication in the initial model, it was always between the IoT devices and the cloud. Now here it is, maximum time there is the interaction between IoT to the fog, but fog is very close to the IoT devices, and rare communication with the cloud. Why there is a requirement to communication with the cloud? Reason is that fog may have the interaction with only limited number of IoT devices. So whatever local parameters have been aggregated here, it is not shared with the local parameter here, with also the local parameter here. So whenever they all aggregate, they are communicating to the cloud. As a whole, this will be able to produce the global model. Otherwise, this model which has been prepared to the fog service is also local, but local involving the 3 IoT. That is better than single IoT, but it is not better than the cloud global model, because the cloud is attached with all the IoT devices, but each fog node it will be attached with only the limited number of IoT devices, right? So here it is. There are 3 approaches. But how much time I should have? I forgot. Sorry?
45 minutes.
It's already over. Huh?
The leaf node can be just like clustering of.
Yeah, I'll come to that part. Now, just let me. What should we do? Should I continue or means? Can continue. Till my last slide, right? Till my last slide.
Some of the.
Oh, Professor sir. Oh, I'm sorry. Okay. Achha, okay. Achha, okay. I'll go.
Details you can.
15 minutes.
Okay. No problem. Another 15 minutes.
Okay, thank you very much. So what I did, here all the IoT devices are actually clustered. As I already spoke that all may not be treated as a client. So out of them, we are actually selecting some of the CHs as the clients. And this CH selection that is based on the intra-cluster distance and as well as the residual energy and then processing power. Then the local IoT devices, they will send the data to their CHs. Then it prepares the model parameters again sent to the fog nodes. This way it will be communicated, and after the aggregation it will be sent to the cloud and then again flow, etc. Right. Whenever the global model is reached to the CH will deliver the global model to all the IoT devices. This is the approach. But here it is interesting that the same thing I want to mean. Okay, I'll come to that particular picture. So this in the first case, I didn't send any kind of the data. It was kept all with only the change. Here we are partially sending the data, compromising some kind of the partition, partial data. This is the only difference. The rest of the steps it will be same. Next, it will be the decentralized approach without the help of the cloud. CHs, they send the local model, and the local model they exchange each other, aggregate it, and again sending back, etc. Without any cloud. There are the 3 approaches.
So you compare these 3 approaches.
Yeah, it was compared. We are getting the better result in the first one, because we are not sending any kind of the data, it's just taking that. Now, this is the communication efficient federated learning. Recently communicated. I'll not go for all the details. This is because due to the time lag. Set up the IoT devices fog node, The main concept is that, look here, just t times t plus t times c times we are aggregating. There is a communication between the CH and the form node, and at t plus c times we are sending to the cloud. So there is a, say after 20 iteration we are sending it. Then again the global model is being sent to here. The next 20 round again we continue aggregation. Then we send it. So number of rounds here it will be much than communicating to the cloud itself. That is the main thought. And this is the energy model we have actually used it, right? And this is the delay model with the two important parameters. This is our method. The first method we are supposed to perform the clustering operation, right? And clustering, it is not usual clustering technique, hierarchical or big scale or whatever be the case. It is based on the distributed energy and the interdistance cluster. And then, yes, and then look here, in the previous case, here it is that how to decide that which particular CH will be uploading the local parameters to which particular form node. So that's why there is a separate algorithm for the case of the form node selection. And if we have, this is that basically NPR problem. This is the clustering. Look, there are m to the power k possibilities for the form node selection because there are k CHs and m number of form nodes are there. So for a high value of k or m, this is basically NP-hard problem. So that's why we have used the meta-heuristic approaches like genetic algorithm. And this is our chromosome representation. This is the CHs T1 that will be allocated to the form node 1. Similarly, as to this is one but it may not represent the best solution because we require the refining of it through the mutation and the crossover operation. That exactly I try to point it out. And again, for the selection, we have used the Ravel field. Right, this is the basically algorithm, shape selection and modulation process. And this is the result. Okay, that part actually omitted it. In most of the cases, we just leave the experimental result and try to communicate it. But it should not be stopped here. We need to validate it statistically. That's why we perform ANOVA test followed by the post-hoc analysis. Okay, that result I have not stored. Right. Now, lot of open source systems are there for the FL, especially the TFL that is developed by the Google, and this is based on the TensorFlow. And you know that Pi, it is based on the PyTorch and then TensorFlow. And then parallel FL is there, FeedML is there, Feed, etc. there. You know, the Google actually introduced the concept of the federated learning. So that's why people really believe on the TFL. And this is very interesting to note that all these open source, you know, we are able to customize it as per our need. So we can carry out. It is not through the another platform. We should actually remind you, especially the scholars or the new faculty members, that we can see whenever we will be dealing with the enormous amount of the data. Only our laptop or the desktop it will not work because they have the limited power and they do not really parallel processing capability. So better to use our student, actually my student, I advise to work only with the Google product. And it is a fantastic platform, Google product. Like the overlay, we never type in the latte, and it's a super facility.
I actually
drawbacks while after 12 hours is very
Okay, everything is there. Even the Google Colab.
Google Colab.
You know, Google Colab, what will happen you cannot do much, but if you want to do much, then subscription charge, it is huge, like AWS. For the initial work, you can do it, but it's very difficult. Anyway, these are the open sources which you are able to customize it. And then these are the applications areas, already I spoke about it. Now, emerging challenges to the deploying the existing algorithms to reduce the communication time. We require the statistical heterogeneity. I talk about the ID and non-ID. Data cleaning and the false data injection is like data provisioning is another serious challenge with respect to the security. Reducing energy consumption because IoT devices, they are battery powered. And then managing drop participants, this is very much important. We have selected the clients, but some of the clients, they actually drop out for the FL process. That actually helps the optimal model creation. And then privacy preservation is also very challenging issue. Now, this is the feature direction, but among all of these, I actually prefer the model and then communication, reducing the communication delay, and then I prefer the mobility of the clients. And the clients not need to be safe. That is also very challenging. So there are quite a few future directions where the people still can work on it. So these are some of the references, and you know that I started preparing the slides related from 2020, even the 21 survey paper. One key paper is here. With that, Mithun is also very good guy. He wrote that IEEE like survey and then tutorial with the high impact factor 39. And we are lucky enough that we could able to we have been able to publish one like survey paper in there. But this is related to the charging problem in the wireless sensor network. Not the Asian computation. This is the IEEE tutorials, surveys, and then tutorials. That is a very high impact. Another paper is there. But federated learning in the IEEE is the tutorial paper is there. That is a very key approach. And then whenever I was refining my presentation, I saw that in the year 2023 also some survey control in a very newer way. Say, for example, they have taken care of privacy. So some of the slides I have actually modified it. 50% modification I have made. That's it. Because I had the presentation in the Venice University. It was in the month of May. So I refined it, then I find that it was very much useful. So that particular paper is there. Still, if you have any kind of questions, okay.